Good morning, class. So in this live lesson recording today, we're going to be going over Unit 5, Lessons 1 and 2 notes, which is all about adding and subtracting radicals. So just as a little heads up on Unit 5 is all about radicals. So what is a radical? We'll talk about that in just a second. And today we're specifically going to be talking about how to add and subtract radicals. Okay, so a radical, what is it? So we are very used to seeing this kind of radical. So like let's say square root of 16, that is a radical. Okay, so we know that the square root of 16 is 4. We probably remember that back from, I believe it was Unit 3 or Unit 2 and 3. I think Unit 2 and 3 we did some radicals. So that is the square root of 16. Technically, you don't see it, but there is like an invisible 2 here to indicate that it is a square root. Okay, we also have a cube root. A cube root would be with a 3. It's also known as a third root. You could also call this a second root here as well. And so like if we did the third root, in this case it's the third root of 64. So square root is what number when multiplied by itself gives us that number underneath the square. It's also the opposite of a square. So a square root is the opposite of a square. So 4 squared is 16, right? But the square root of 16 is 4. They undo each other. So a square root and a square, or an exponent of 2, are literally the opposites of each other. Okay, so in this case, we're saying what number, when multiplied by itself 3 times, gives us 64? Well, that would be, in this case, 4 as well. Because 4 times 4 times 4 is 64. And for those of you that don't know how to do this on a calculator, we'll go ahead and show you how to do that. I'm going to move some things around here on my screen. So I did this a little bit earlier, but we'll go ahead and delete it so we can see it again. So if we're doing anything other than a square root, so this button is like the automatic square root. Technically, I could also do a square root using this by just putting a 2 there for the index. That's called the index. Okay, but let's do a third root here of 64. So I'm going to hit this n with the square root symbol. The n allows me to change the index or the root, and then I can click underneath to change the radicand. The radicand is the number that's underneath the square root symbol, and so then that would be 4 in this case. So the third root of 64 is 4, or the cube root of 64 is 4. Okay, so back to, and we'll do some more with that. So parts of the radical. So what are each of these different parts called? So we kind of already mentioned that this number here is called the index. So that just tells me what root it is, or another word would be root. Either one of those would be fine. So we could call that the third root. We can call that the cube root, or the index of 3. Either one of those would work. But typically, I would say the third root or the cube root in that case. All right, so this number out front, a lot of times we have numbers like 4x, or when we were doing scientific notation, we had a term called coefficient. So coefficient is the number out front. So that's what this is also called, the coefficient. So the number that's in front of the root symbol is called the coefficient. Just like if we have 4x, the 4 is considered the coefficient. Okay, and the last part that we have is this number underneath is called the radicand. So that's the number that we're taking the root of. So in this case, it would be the third root of 64. So that is called the radicand, not the radical. Whoops. Radicand. All right. So that is the different parts of a radical: the coefficient, the index, and the radicand, or index or root. All right, so now we're going to talk about the rules for adding radicals, or numbers that are in radical symbol. So, two things that we need to do, or two things that must be present in order to be able to add them, is they have to have the same radicand. In other words, they have to have the same number under the root. Okay, so like for instance, in this one we have a 9 and a 9, so we can add those. And they also have to have the same index, or the same root number. So in this case, they don't have a root number. Notice there is no like little number here. So we automatically know that it's a square root, by the way. Okay, so in this case, as long as we have those two things present, which we do, they both are a root of 9, and they both are a square root of 9. So all we have to do is simply add the numbers in front. So 2 square roots of 9 plus 4 square roots of 9 is 6 square roots of 9. Now we know what the square root of 9 is. We know that square root of 9 is 3, because we did that back in Unit 2 and Unit 3. So this would simply be 18. Now I think on the actual quick check you're probably going to have this as the answer because it's trying to keep it in root form. All right, question number 2. Again, the number in the radicand is the same, so they both are 26, so we can add them. And they have the same index, which in this case is no index, which again, when there is no index, it's like there's an invisible 2 here. So even though it doesn't show that, there is an invisible 2. So, and then this time, how many square roots of 26 do we have? Well, each of these is literally just 1 square root of 26. So like technically there's kind of like an invisible 1 here as well. But if I have a square root of 26 plus a square root of 26, I have how many square roots of 26? I have 2 of them, right? There's 1 here and there's 1 here. So add those together and we got 2 square roots of 26. And now in this case, the square root of 26, we don't know what that number is. It's not an improper fraction, sorry. I've also been teaching fractions in my college class. But no, it is it's going to be an irrational number. So if I take the square root of 26, you can see that it's not a whole number. So 5.0990195514, and technically that number goes on forever and ever, and it doesn't repeat itself. So 2 square roots of 26 is where we would leave that. We will talk about how to simplify a number like this later. Actually, in Algebra 1, you'll do that a lot, but for now, we're just going to leave it as 2 square roots of 26. All right, question number 3. We have 7 square roots of 5 minus 4 square roots of 5. Again, the radicand is the same. They're both 5s, okay? And they both are square roots, even though, again, there's an invisible 2 here. So all we have to do is subtract. So 7 minus 4 is 3. So that's 3 square roots of 5. That would be our answer for that. Pretty simple. This is a number minus itself. So, I mean, imagine if it was 1 minus 1, it would be 0. So anything minus itself is going to be 0. So that's just going to be 0. Because we have 1 square root of 32 minus another square root of 32. So 1 minus 1 is 0. So that would be 0. All right, this one, it says the tiles at a store are being compared. The diagonal of one tile is 9 times the square root of 2 centimeters, and the other tile is 8 times the square root of 2 centimeters. What is the difference in their lengths of the diagonal? So this is just difference. Whenever it says difference, that is a subtraction problem. So it would be 9 square roots of 2 minus 8 square roots of 2. So the difference is 9 minus 8. Again, they're the same radicand. Both have 2. And the root in this case is a 2 because it's an invisible 2. Okay, anytime there's no root, we just assume it's going to be a square root. Okay, so 9 minus 8 is 1, so that would be 1 square root of 2. Or we could just leave it as square root of 2 because any number times 1 is literally just that number, so it's literally just the square root of 2. That would be the difference in the diagonals of these two different tiles. So that is it for Unit 5, Lesson 2. Really, this is mostly just Lesson 2. Lesson 1 is just the introduction to the unit. So that's it for the notes. If you guys have any questions, feel free to book some time with me. Otherwise, have a fantastic rest of your day.